Hi, this video is going to cover angle properties of triangles. The learning goal for this video is to determine missing angles in triangles using geometric properties. We're going to go through some simulations that are going to uncover some of these properties that are going to be very useful for us when we're solving problems involving missing angles. We're going to go over very briefly a couple properties of angles that you may or may not know about. So we're going to look at complementary angles and supplementary angles. So here in complementary angles, you notice that we've got two angles here, but together I know that they add up to 90 degrees. You see this box here. That means that as this big angle here, as a whole is 90 degrees, but this part here is 70 and this part here is 20. So we're going to use the fact that these two angles add to 90 degrees to help us figure out this missing piece. So that part is 70, and I'm looking for this other part that should together make 90 degrees. I'm going to do some simple subtraction here. So 90 degrees take away 70 degrees should give us the remainder, which is 20 degrees. Okay, so this part here that's missing, this part here is 20 degrees. Now, supplementary angles here are two angles that add up to 180 degrees. So this is a straight angle here. And again, we're going to use the same strategy. These two together should make 180, yet this one is just 140. So to find out what that missing angle is, we're going to do 180 degrees, take away 140 degrees, and that will be 40 degrees. All right, so that missing part here is 40 degrees. We're going to use these two properties a little bit later on, but first we're going to take a look at some simulations here that are going to look at 5 things around triangles that are going to be really important for us. Okay, so I'm going to go over here. Oops, that one's to the end. Let's edit that. So we're going to look at 5 simulations now that are going to uncover some properties of triangles that we really need to know. So the first one here is the triangle sum. Okay. So what we have here are just one triangle with 3 angles here. You can tell that the 3 angles here right now, they add up to 180 degrees. Well, that might just be a coincidence. What we're going to do is I'm going to move this triangle. And you can tell that no matter how I move this triangle, okay, the angles are changing, but their sum is always 180 degrees. Okay, so that's a fact of triangles that we need to know, that all 3 angles in a triangle add up to 180 degrees. We're going to look at an isosceles triangle. So in an isosceles triangle, 2 sides are equal to each other. All right, so I'm going to make this bigger. So you can tell that the side here, AB, is 7.74 units, and side AC is 7.74 units as well. So this is an isosceles triangle, and no matter how I move this, this will always stay an isosceles triangle. Now, if we look here at the base of these 2 sides, these 2 angles seem to always be the same. All right, now if I move this around, if I change this triangle, no matter what, the angles at the base of these 2 sides, of these 2 equal sides, are always equal themselves. Okay? So those angles are always the same in an isosceles triangle. So that's an important fact. All right, we're going to look at an equilateral triangle, which is a triangle where all 3 sides are the same. So let's take a look at what happens with those angles. So this is going to go through the creation of a equilateral triangle. Now you see there's a pink angle there on the left-hand side. If I slide this over, that same angle fits perfectly into the bottom right corner as well as the top. So all 3 angles in an equilateral triangle are the same. And because all 3 also add up to 180 degrees, like in any triangle, then that means that each angle has to be 60 degrees. Okay, so that's an important fact. Now if we look at this simulation here, we're looking at the exterior angle. So when you extend each side of a triangle, it creates an angle on the outside. Okay? So we're going to look at one of these and how it relates to angles that are farthest away from it. Okay? So I'm going to slide this over. That pink angle there fits in one part of that exterior angle, and that green second angle fits perfectly into the other side. Now that might be, again, just a coincidence, right? So I'm going to move this triangle, okay? And no matter what, okay, if I slide this over, both parts of those two angles that are farthest away from the exterior angle, it fits perfectly there. So the fact here is that the exterior angle triangle is always equal to the sum of the two angles that are farthest away. We're going to look at one more simulation here together, and this one talks about the exterior angle, or all three exterior angles in a triangle. So if I'm going to slide this over, and you notice that those three angles together make up a circle, a full circle, which is 360 degrees. Now, again, that might be a coincidence. I'm going to just move this triangle. I'm going to change it up a bit, but no matter what, those three pieces slide together and they always make a full circle of 360 degrees. So that's one more fact around triangles, that the exterior angles, all three of them, they always add up to 360 degrees. So that was a lot that we just uncovered. So in summary, let's just look at them one more time. That the three angles in a triangle, they add up to 180 degrees. The two angles at the base of an isosceles triangle are equal. The three angles of an equilateral triangle are all equal, okay, and therefore they are 60 degrees each. The exterior angle of a triangle is equal to the sum of the two farthest interior angles. And the exterior angles of a triangle add up to 360 degrees. So we're going to use these facts to help us solve some of these puzzles, basically, where you're going to be given information about each triangle, and it's your job to try to figure out what that missing piece is. So if we take a look at this first question here, I'm given two angles in a triangle out of three. So I know for a fact, okay, that these three angles together have to add up to 180 degrees. So I'm going to use that fact, and I'm going to, let's add these two together first. Okay, so I'm going to write here 82 degrees plus 57 degrees. That's going to be 139 degrees. So I know that all three, though, have to add up to 180. So I need to find out what's missing from 180, okay, so that when I find x, that missing piece, when I add it to 139, I will get 180. So I'm going to do some subtraction. So 180 degrees, take away 139 degrees, should equal to 41 degrees. All right, so in this case, that missing angle x is 41 degrees. We're going to look at this problem here. So here's an exterior angle of 148. Now remember, we said that the exterior angle is equal to the sum of these two farthest angles. So I need to know what piece, so what added to 88 will get me 148. Okay, so again, I can just go through some subtraction here. So 148 degrees, take away 88 degrees will get me that missing piece, which is 60 degrees. Okay. So in this case, x is 60 degrees. Okay. So we're going to look at problems that sometimes involve multiple triangles. Now, for this question here, C, you can see that it's actually one big triangle, but there's a little triangle kind of embedded inside it. So our job is to find x here. Now, usually in problems like this, you don't just do one calculation like we just did. You're going to have to find some information in between and then you'll be able to use that information to help you find what you're really looking for. So in this example here, we have an isosceles triangle, this little one here inside, and I can find some information about that triangle, which will then help me to look at the angles inside this bigger triangle. Okay, so remember, in an isosceles triangle, if these two sides are equal, then these two angles are equal. Okay, so that means that this angle here is also 76 degrees. Now I can use that fact to then help me find this angle here. So remember, all three angles in a triangle add up to 180 degrees. So 76 degrees plus 76 degrees, that will get me 152 degrees. So to find out what that missing part is, I'm just going to do 180, take away 152 degrees, and that will get me 28 degrees. Oh, this thing's kind of lagging on me here. 28 degrees. Okay. Now, I know, let's look at this big triangle here. So this angle here, okay, it's a right angle. So I know that that is 90 degrees. So what I'm going to do is, I know that top angle there, that top angle here is 28. This one here is 90. So now I can use those two angles to help me find x. So I'm going to do 90 degrees. I'm going to add that to the 28 degrees. So that is 118 degrees. Now what I'm going to do is I'm going to take that away from 180 degrees, and that will get me the remainder here. So 180 minus 118 will get me 62 degrees. Okay, so I'm going to write down here x is equal to 62 degrees. So I had to find out information about the about a triangle that I initially didn't really focus on, okay, because I'm trying to find the big angle x here. Okay, so I had to find information about another triangle to help me find information about the angle that I'm looking for. Okay, so that's the moral of the story when we're looking at problems involving multiple triangles. So again, let's look at this one here. I'm looking for angle D here, and I'm not just going to be able to find that with one calculation. I'm going to have to do a few things before I do that. So I'm going to look over here. I again notice an isosceles triangle. So again, if these two sides are equal, so that angle is 44 degrees, then this angle here is 44 degrees as well. So again, now if you know two angles in a triangle, you'll know the third one. So I'm going to add 44 and 44 together. Okay, so that should give me 88 degrees. And now what I'm going to do is I'm going to subtract 180 from that. So that will give me 92 degrees. So that angle here is 92 degrees. 92 degrees. Okay. Now, these two lines here are crossing. So that means that this angle here is equal to 92 degrees. Okay, so that's called the opposite angle theorem. If you didn't know that, well, now you know. So these two angles here are always going to be equal because they are on the opposite sides of two lines crossing together. Okay, so that 92 and that 50, okay, and that D together should be 180 degrees. So again, we're going to use that strategy. Let's add those angles together. All right, so 92 plus 50 will get me 142 degrees. And then what I'm going to do is I'm going to take 180 degrees, take away 142 degrees. So that should get me 38 degrees. Okay, so that's what D is. Okay, so again, we had to find information about a separate triangle to help me get information about the triangle where the angle is nested in. Okay. All right. So I'd like you to try this problem now. So remember that fact. We're going to have to try to find information about one triangle beside it to help you get information about the triangle that your missing angle is in. Okay. So I'd like you to pause the video now, give this problem a try, and then when you're ready to look at a solution, press play. So go ahead and do that. All right, I'm going to assume you paused. So let's find out some information about this triangle. So remember, this is an equilateral triangle, so that means that every angle inside it is 60 degrees. Okay, that's good to know. Now, that'll help us because over here is a straight angle, right? What we talked about earlier. So that means that these two angles will have to add up to 180 degrees. So this angle here, which I can call angle ACD, okay, so the C is the middle letter because it's the middle of that angle there. So I'm going to write angle ACD. So that's going to be equal to 180 degrees minus 60 degrees. Okay, so that's going to be 120 degrees. So this part here is 120 degrees. Now, this angle over here is 25. This is 120. So what's missing here is just going to be the third piece where those will add up to 180. So I'm going to do 25 degrees plus 120 degrees. That will be 145 degrees. And then I'm going to do 180 degrees minus 145, and that will get me 35 degrees. So that's the missing angle right there. Okay. So again, finding information from one triangle will then help me to get information about the triangle where my angle is located in. Okay, so that's all you need to know about triangles and the angles inside and outside of them. And hopefully you can now find missing angles in these sorts of triangle puzzles. So best of luck.